So in this video, I'm going to teach you how to determine the formula of an unknown hydrate. Now, you were also supposed to have some practical experience with this in the lab, but since we can't do it, the next best thing is we're going to watch a video of the lab being done, and I'll explain what's happening in that lab as the work is being done. Okay, so all right, so this is to determine the formula of an unknown hydrate. What that means is we know the formula of this blue compound, I believe it's copper sulfate, but we don't know how many water molecules are attached to it. So that's the unknown part, okay? So let's watch the video and I'll explain it. So here's copper sulfate. We don't know what the amount um, for the hydrate is. So just watch what they're doing. They're just going through the process of the lab. They mass the evaporating dish. They're going to record the mass of the evaporating dish with the hydrate sample in there. That's 54.76. I'm just going to fast forward through and grinding it. It's just increasing the surface area um, to get the water to evaporate more easily. Transfers it into a dish, and then we heat it because the best way to get rid of the water is to heat it. So now that all the water has been evaporated, the copper sulfate has changed color. It's completely white now, so you can stop the heating. And then you have to let it cool down, and you have to take the mass again. So it was 54.76 before, and now it's 50.46. So that means before you heated it up, it was the hydrate, which means it contained water. After you finish heating it up, all the water has evaporated and now it's 50.46. That means all the water that evaporated, you can find its mass by taking the mass of the hydrate before you heated it and now the anhydrous version of that hydrate after you've heated it. Okay, so now you can do calculations based on what you just did. So let me. This part that we just saw was supposed to be done in the lab. So here's what that person did. They masked the hydrate. That was the blue crystals. You took the mass of that, and if I remember correctly, it was 54.76 grams. Okay. Then they heated it to dehydrate it. They actually ground up the crystals to get more surface area for the water to evaporate, but they heated it to dehydrate it. Once you've dehydrated it, you have the anhydrous compound. Remember, anhydrous means without water. So evaporating all the water leaves you with the anhydrous compound, and then they masked the anhydrous compound, and that was 50.46 grams. Okay, so you can easily find the mass of water by looking at the difference between the hydrate and the anhydrous compound. So I like to kind of just simplify this and call this the wet and this the dry. So you just have to take the difference between the wet and the dry, because when it was wet, it was the hydrate. When it's dry, it's the anhydrous. If you take the difference between the wet and the dry, you have the mass of water here. Okay, so in this particular case, you have 54.76 minus 50.46. The mass of water was 4.3 grams. So the mass of water was 4.3 grams. That means 4.3 grams of water evaporated when the hydrate was heated. Okay, now that you have the mass of the anhydrous compound and the mass of the water, you are ready to do some calculations to determine the formula of the unknown hydrate. Okay, the anhydrous compound is just a plain ionic compound, and then you have the water as well. Okay, so let's go see how to do this type of problem. Now, here are all the instructions. You have to do these calculations. Like the problem that you'll be given will be presented like it was done in the lab. You'll be given a bunch of data. So you have to take that data and do a real calculation with it. Okay. So you'll be given the mass of the anhydrous compound. That's the mass of the dry stuff, and then you'll be given the mass of the water that actually evaporated. If they are given as percentages, you can turn them into masses just like you did in percent composition. Okay. The second step you do is to convert the masses of both to moles. Then you divide all mole values by the smallest mole value. This is just like what you did for empirical formulas. And then once you have the number of water molecules, you write your answer in the proper format of a hydrate formula. That means ionic compound dot and then some number of water. Okay, this is the um, form that the hydrate formula should be written in. So let's do an actual problem. Okay, so here's a question. Cerium iodide or cerium 3 iodide occurs as a hydrate with the composition of 76.3% cerium iodide and 23.7% water. They want you to calculate the formula of the hydrate. So what you are trying to calculate here is cerium 3 iodide dot, you don't know what this x is. That's what you're trying to calculate. How many water molecules go over there? Okay, so they tell us that it's 76.3% cerium iodide and 23.7% water. So since that adds up to 100%, we can directly translate these into grams. So you have 76.3% cerium iodide. That means you have 76.3 grams of cerium iodide. Then you have 23.7 grams of water. Then convert these into moles. So you end up with moles of CeI3 and moles of H2O. Now, molar mass of cerium iodide is 520.82. So 520.82 grams of CeI3, 1 mole of CeI3 on the top. Okay, then 1 mole of water here on the top, and 18.02 grams of H2O on the bottom. So grams of cerium iodide cancel out. You are left with 0.146 moles of cerium iodide. Then you have 23.7 grams of water. Okay. Um, the moles for water is 1.315 moles of H2O. Now that you have the moles of cerium iodide and the moles of water, you have to do step number 2 here. You have three here. Sorry, you just did that. You converted the masses of both to moles. You have to divide all mole values by the smallest mole value. So here is what you do. I want you to write it like this when you do this. Okay. CeI3 is 0.146. 0.146. You write the dot, then you write X H2O, and this is 1.315. Remember, you have to divide everything by the smallest mole value, and the smallest mole value is 0.146. So 0.146 is what you divide both things by. Okay, so let me divide that and tell you the answer. So 1.315 divided by 0.146 gives me 9, and this is just 1. So the ratio of cerium iodide to water is 9. So what you just found here is the number of water molecules that is attached to cerium iodide. So that number is X. Now you just have to finish the problem by writing the correct formula or the format for this hydrate formula. So your full answer is cerium iodide nonahydrate. Cerium 3 iodide nonahydrate is the formula for your unknown hydrate.